On page 206, you can just move the fan, Ryan. Unplug it and bring it over here.
That's too
Or back there.
really complicated.
Or you could put it in your binder. Or you could move.
You're in grade 12 physics.
Yeah, you should be able to solve that. Okay, I want to remind you of the following formulas. V equals 2 pi r over t.
Do we have, no.
These are just a reminder of ones we've already seen. 2 pi r over t. A equals v squared over r, and a equals 4 pi squared r all over t squared. Now, I've told you about how t, the period, and f, the frequency, are related, right? About how they're inverses from each other. So the textbook actually goes so far as to give you a couple other formulas, which you may want to throw into your toolbox. Because 1 over t is equal to f, yeah, that would mean that 1 over t squared would be equal to f squared. Here I have this t squared, see that? So I can replace this over t squared with an f squared. And so this one here becomes 4 pi squared r f squared. Do you see what happened there?
No.
I'll say it again.
Oh, F, that would be T again. Just F.
1 over t is equal to f. So 1 over t squared is equal to f squared. And so now this over t squared is replaced with the f squared. Okay? So it's this formula again, just version 2, worded a little differently, right? F squared.
That's what I was teaching for so long.
F squared. Does that make sense, Ryan? Yeah? Okay. That's not it. Ryan came to me yesterday with a question from a sheet that led me to, oh yes, I need to talk about this kind of thing. So this is the same kind of thing, Ryan. In fact, was it an ant or? It's the exact same question? Was it on the sheet?
Yeah.
Oh, okay, that's weird. Okay, well, let's talk about this one here. Okay, so Hannah, I'm beginning.
I'm ready for you.
Excellent. So here we have a very small flea. He weighs 0.2 grams, sitting at a distance of 5 centimeters from the center of a rotating LP record. Bonus marks if you know what LP stands for. Long playing.
Well,
It means they have 5 songs on the record. You don't have to get up until 5 songs have played. Oh, the good old days. The record rotates at 77 RPM. Anyone?
Revolutions per minute.
Exactly. What centripetal force must be provided by friction to cause the flea to maintain its UCF? In other words, how much friction force? Oh, I think your question was the mu value, I think, Ryan, right? Yours was actually harder than this one. I think so. Little bug. Okay. Yes. Okay. So here we go. There's the center, and here's our little bug, right? So what basically I'm asking, what's the centripetal force here? And what's it provided by? It's provided by friction. Okay, so what do we know here? Let's do some conversions. The mass is 0.2 grams, divide by 1,000, that's going to be 0.0002 kilograms. And our radius of orbit is 5 centimeters, which is 0.05 meters. 77 RPM, is that the frequency or is that the period? It's a way of expressing the frequency, right? So it's 77 per minute, so 77 in 60 seconds, right? Do we want the period or do we want the frequency? Doesn't matter. We can convert, right? Okay, so what is 77 divided by 60? I don't mean the number. I mean, what is it?
1.28.
Okay, 1.28. But is that the frequency or is that the period? That's the frequency, right? 1.28 hertz, or revolutions per second. If it makes 77 in 60, how many does it make in 1? Divide 1.28 revolutions. That's the frequency. Okay, so what centripetal, basically I'm just looking for FC, am I not? Can I use this guy right here? Oh, this is only for the acceleration. How do I get it into force? Put an M in front, right? So centripetal force is going to be M4 pi squared RF squared.
I said that.
Remember those good old days when you could do the magic triangle and there was only 3 letters in a formula?
Now,
Ah, the good old days. M4 pi squared RF squared.
why did you?
I put the M in front, Hannah, right? To make it a force. Because I'm solving over here, I'm solving for force.
Yeah.
I'm solving for force. You could do that. You could find the acceleration, yeah.
So now we're just adding, because that's the formula for acceleration, right? So if we time.
Thank you, Jason. Okay, so this is going to be, hey, this is all you got to do, right? M4 pi squared RF squared. Holy. So 0.0002 times 4 pi squared, radius 0.05, frequency 1.28 squared. Can you imagine having to do this without a calculator in the good old days? Say again, Brain? You could divide by t squared, yeah, but we've already got this, right? So. I get, do you get this really tiny number? 0.00646865 newtons? Is that what you get? So, you haven't seen this type of thing yet, but when I show it to you, it's like, hey, that's not that bad at all, right? Do you understand why the friction is the friction is causing the centripetal force? As it rotates around, the bug wants to do what? Go on a straight line, right? But he doesn't because of friction. It's no different than when you're driving your car around a corner, right? It's actually friction that forces you towards the center, which is really an unbanked curve, which we'll talk about on Monday. Jason, you have the textbook there, or you got it away, right? I was just going to say, is that the answer they show in the book?
Oh.
I got it right here.
Oh, problem.
Do you have faith? 625 times 10 to the minus 4.
Yeah.
4, yep. That's not too bad. That's not too bad. All good?
So what do we find the view? Like in the, oh, so that's our friction.
You wanted to go that far?
Yeah.
Okay.
You just have to find like the FN and then.
Yeah. So, what, Ryan, in the question that he asked me, it was about the mu value. So to do that, mu equals FF over Fn, right? This Fc is equal to the FF. The Fn is our mass times gravity, right? So that's going to be m times g. This is not part of the question, but let's do it now. Point 00196. And so the mu value, now, okay, before we do this calculation, would you expect a really big mu number, or would you expect a really small mu number?
Big one.
And don't just guess, can you explain why?
Wait, is it FN over FF?
FF over Fn. The FF is the FC.
Well, I'd expect a fairly large mu number, not like super big, but not.
Like in the 0.8 kind of range?
So maybe kind of mid-range.
Yeah? That seems like you're kind of sitting on the fence a little
Is it
bit.
necessary to find the?
Oh, yeah. How would you sleep tonight?
Part, but is it question?
No.
So
It is
there's 3 Ds for
on
fun?
the sheet that we got.
Oh,
There's one coming up with that, so.
okay, so we're gonna do this in another question.
Well, we're gonna do it now for funsies.
But can we do it again later?
Oh, yeah. Yeah.
So I'm not gonna wait.
Oh.
Try.
0.33. Now, what would happen if the mu value was bigger than that, Ryan? What if it was like 0.8? What would that mean to our fly friend?
He'd just be stuck on the thing.
Yeah, he'd be no problem, right? It would be if the mu value would be too small, right? If the mu value, actual mu value was say 0.1, then he'd have no chance of staying on there. That's what it would mean.
Makes me stop.
Yeah, I will. I'll explain that a little bit later. Okay, here's another one, and then I'll be done. A 250-gram chestnut with a hole drilled through its center. I don't know why chestnut, but I guess. It's hanging from a long massless shoelace. Maybe it's being roasted over an open fire. What do I mean by a massless shoelace?
String's nothing to do with math.
Yeah, we're not going to worry about the mass of the string. A child spins the chestnut in a vertical circle at a speed of 4 meters per second. If the shoelace is 0.8 meters long, determine the tension in the shoelace at the top and bottom of the circle. We've done these kind of questions already, haven't we? Yeah.
Oh, this is just like the lab yesterday, right?
Yeah. No, because that was a cone, right? That was not quite. This is sort of in between the two. Okay, so what would be the centripetal force? Well, that would be mv squared over r. 0.25 times 4 squared over the radius 0.8. Five newtons. Is that it? Okay, Lana, here's the part where you should listen. That's the average force, but at the top, gravity helps that out, so the tension in the string is less, but at the bottom, gravity works against it, right? Okay, so the weight force is, and we sort of did this, I might have been writing it a slightly different way here. The gravity force is going to be times 9.8. .45. So at the top, it's going to be what? 5 minus 2.45.
Yeah.
That would be the tension, right? So this is going to be, which means at the top, right, the tension is providing 2.55 newtons, and the weight force is providing 2.45 newtons. At the bottom, what's going on? The tension is going to be the same thing, except you add. I sort of did it a little bit more complicated in the samples before. I think this is probably a little easier to follow.
Did you use like negatives?
Yeah, I had all that sort of stuff. Some people want that, Jason, so that's why I do it that way. Some people just want it simple like this. So I'm providing you both sort of ways to look at it. But it is equivalent. I hate when I do that. Does that sort of make sense? Yeah, pretty straightforward.
Yeah.
Okay, if you do have your textbook with you, there are some questions on page 206, numbers 1 to 6 if you want to try. I've given you 2 worksheets. I'm not going to be